12, 13, and 14, 15 and 16 are asking you to kind of graph it and find some attributes about the graph. And so the domain, vertical, asymptotes, the horizontal, and the holes. So the only one that has a hole is 12 and 13. And so I didn't really mean to put holes on all of these. And so we've talked about this, but I don't know if I've written it out explicitly for you. For the domain, so it can present either a vertical asymptote or a hole. And then we haven't really mentioned much about the range. The range is similar to the domain. That's all. This is your x values. The range is your y. The range the range is going to be all real numbers except for the horizontal asymptote. And wherever the hole was, if you tried plugging in the hole, which we don't really do in this class, but if you try plugging in the hole, there's a y value, but since there is a hole, that y value is excluded. I just want to get you used to that, introduce it to you, but we don't really do much of that in this class. And then the vertical asymptote. And so the vertical asymptote happens where you divide it by 0, and so you can't divide by 0, and so that's where the graph splits. And so similarly for the horizontal, the horizontal asymptote as x gets really, really big is if you go all the way to the far right side of the graph, or when x is really, really small, when you go all the way to the left side of the graph is flattening out. It's approaching a horizontal line. And so this horizontal line is what splits the graph in half up and down. And so holes a hole happens when you are dividing by 0. So there's a division by 0, but a factor on top and bottom canceled. So if you had something like this, x minus 3, x minus 3, those cancel, and so there would be a hole at x equals 3. Like you'd still see in the table you'd see two errors at 3 and at -2, but -2 would give you a vertical asymptote and x equals 3 would give you a hole. And I mentioned in a previous video how to look at finding the horizontal asymptote. There's 3 cases. The first one, you're looking at the exponent. But you're only looking at the first term, top and bottom, because most of ours are written in descending order with the biggest exponent first. And so if the smallest, or the smaller of the 2 exponents is on top, and the bigger exponent is on bottom, that's going to give you a horizontal asymptote at y equals 0. And the next case is if they have the same exponent. That's like 5x over x plus 1, or x squared over 3x squared minus 2, or something like that, where it's x and x, square, square. Or you could have like a cube or something. You look at the first term on the top, the first term on bottom. And you look at the ratio of the coefficients. So on the first one, you have 5x over x, so that would be at y equals 5. Because x divided by x, would cancel out and just leave you 5 on top. This one, the x squareds would cancel and leave you 1 over 3. So 3 would be on bottom. And this one, the x cubes would go away and leave you 1/5. And so this one, personally, I think is the hardest one to see on the graph, especially if you have a fraction. And it's easier to see from the equation. And so if this is the only rule that you remember, if it's the same exponent, you take the coefficients, you'll be fine. Because the other 2 cases are pretty easy to see from the graph. The third one is if you have the bigger exponent on top and the smaller exponent on bottom. That is not going to have a horizontal. That is called a slant asymptote, which you don't really get into in this class either. All you gotta know is that there is none. Like, there is no horizontal because it's slanted.